Hello. With this lecture, we shall start our discussion on various internal mechanisms and technologies used for long distance data communication. The networks used for this purpose are known as wide area networks, and the basic model that can be used to represent wide area networks are switched communication networks. Let us start today's discussion with the basic features of switched communication networks. Switched communication networks. There are two basic elements in it called stations and nodes. Stations are essentially end user equipments like computers, terminals, telephones, and various equipments which are used for the purpose of which are used as end user equipments. And nodes are essentially switches. The network will look like this. Say this is a node 1, node 2, say node 3, node 4, node 5. And you have stations, say A, B. This station is connected to node 1, this is connected to node 2. Another station, say node C, is connected to node 4. Another is connected to node 5, say D. And let there be another station, 6, node 6. Now, these nodes are linked in some arbitrary manner. There is no regularity in the interconnection. It may look like this. And some of the nodes are connected to stations. If we look at the features of this particular network, and this represents the switched communication network. If you look at the basic features, we'll find that some nodes are connected to some other nodes only, some other nodes only. For example, here node 6 and node 3, they are connected only to node 2 and node 5. They are not connected to any other station. On the other hand, some nodes are connected to stations as well, because they are also connected to some of the nodes. Now, the purpose of these nodes which are connected to some other nodes is to provide connection path. So their sole purpose is to provide connection path. They are basically uses as switches to provide path. On the other hand, these nodes, say 1 and 2 or 4 and 5, they are connected to some stations. That means they can be used to provide interface to the user equipments, end user equipments, as well as they will be connected to some other nodes for the purpose of switching. Then you have another important feature, links between the nodes between the nodes are multiplexed. That means the internodal links, say between 1 and 4, 2 and 6, 3 and 4, these are high speed links, and to use them effectively, multiplexing technique such as TDM, time division multiplexing, frequency division multiplexing, which you have already discussed, are used. On the other hand, these links between a station and a node, these are not multiplexed, they are links of lower bandwidth. Another important feature is the nodes are not connected. Nodes are not fully connected. What does it imply? It implies that, say, station A wants to communicate with station D. Station A is connected to node 1, station D is connected to node 5. Obviously, just by one hop, the communication cannot be done. They have to take the help of some other intermediate nodes like 2, 6 or maybe 4 to establish a path. So you have to use some intermediate nodes to establish path between any stations, any pair of stations. Another important feature is multiple path exists between stations. This is necessary to provide reliability. For example, to establish a path between A and C, it can be done through node 1 and 4, or it can be done through 1, 2, 4, 5, 1, 2, 6, 5, 4 and then C. Although this path is longer, but nevertheless it provides a path. This is necessary for the purpose of reliability. In case of some link failure, alternative paths can be established to provide a link. So these are the key features of the switched communication network. Now the nodes are essentially switches. And some switching technique is used for providing links. There exist three important switching techniques. The switching techniques are circuit switching, message switching, and packet switching. Today, we shall concentrate mainly on circuit switching. In circuit switching, circuit switching. In circuit switching, you have several switches. So this is one switch, let's assume, another switch, which are essentially nodes according to our switched communication network model. So these are the switches. Let's assume that there are 4 ports on either side. All the switches are provided with 4 ports for the sake of simplicity, and there is a interconnection path provided between the switches in some manner. And here you have got your stations. Say this is 1, 2, 3, 4. These are the switches, and you have got station A, station B. Say station A is connected to this port, station B is connected to this port, and to 4 you have 2 more stations, C and D are connected here. Now, in circuit switching, there are 3 phases for establishment of the link. These 3 phases are circuit establishment, second is circuit data transfer, and third phase is circuit disconnect. So in the first page, a link is established by establishing a path. So from node A, from station A through node 1, 2 and 4, a path is established. After the path is established, circuit is established, whatever data A has got, it sends through this path, through the circuit, and after the data transfer is complete, it disconnects the path which was established. This can be represented by time sequence diagram. In this way. Suppose you have got 4 nodes, 1, 2, 3, 4. Node 1 is connected to station A and node 4 is connected to station B, and you want to transfer data between node station A and station B. The first phase, that circuit establishment, a call request is sent from node 1 to node 2, and then node 2 in turn sends another call request signal from node 2 to node 3, and node 3 in turn sends another call request signal from 3 to 4. So if there is path available, obviously there is some delay between after it reaches 2, and from 2 to 3, and again from 3 to 4, there are some delays here. And whenever a path is available, an acknowledgement is sent. Now there is no delay, as you can see, because already a path has been found or a circuit has been established. So this is the call acknowledgement. So after this call acknowledgement is received, the circuit is available to the user or node station A, and it can transfer whatever data it has got, and it will send entire data, or we can say message, entire message is sent through the circuit already established through nodes 1, 2, 3 and 4. And after the data transfer is complete, an acknowledgement is sent through the already established circuit, and then this is an acknowledgement, and after the acknowledgement is received, the circuit disconnection is done either by node A or by node B. It can be initiated from either of the ends. So this is how the uh, the data transfer takes place in a circuit switched network. The best example of circuit switched network is public telephone network. Public telephone network is the best example of circuit switched network. Now in public telephone network, as you know, each country has a number of has the telephone network, which we call national telephone network, and the national telephone networks of different countries are interconnected to provide an international telephone network. And although this telephone network was originally designed for analog voice communication, nowadays this is widely used for data communication using modems. And some of the exchanges or path between the end user and the telephone network is available in digital form. Let us look at the important components, 4 components of public telephone network. You have your end user equipment, let it be a telephone box, and another end user equipment, let's assume here another telephone box. These end user equipments are connected to what is known as end office. So the first component is the subscriber equipment. It can be a conventional handset, or it can be a computer equipped with a modem, and that modem is linking to the end office. Now this path is called local loop. This local loop is a link between the end office and the end user equipments, the telephone or the modems. Now these end user, these local, the end offices are connected to toll office. Toll offices. I am providing 2 lines to indicate that the bandwidth of this path is higher than this path. And the toll offices are in turn connected to what is known as intermediate switching offices. This is intermediate switching offices, and these paths are called toll collecting trunks, toll collecting trunks, and this is actually very high speed these toll collecting paths are very high speed inter toll trunks. These are inter toll trunks. Let us look at the basic features. First of all, the subscriber equipment, the first component, is a handset, or it can be a computer with modem, as I have told. The local loop is a pair of wire I have already discussed the twisted pair as one of the very popular transmission media, and this is where it is used. A link between the local office, end office, and the end user equipment, or you can say from the telephone exchange to the different houses where the end user equipments are located. And each end office can provide several thousand connections. That means from each of these end offices, several thousand connections are going to different houses with the help of twisted pair of wire. On the other hand, these toll collecting trunks or inter-toll trunks, these are very high speed links where optical fiber then you can use coaxial cable, you can use optical fiber, coaxial cable, and various other techniques. I have already discussed the various techniques, high speed techniques that can be used for that purpose, and these are in multiplexed form, that is by using time division multiplexing or frequency division multiplexing. So the four components are number one is subscriber equipment, second is end office, third is the switches, and fourth is these links, these toll collecting trunks. So these are the four important components of the public telephone network. Now, how the communication is established in a telephone network? Here, let's assume we have got end user equipments, so these are end user, sorry, these are your end offices, and you have got ports provided with it where the end user equipments are connected, as I have shown. Another end user, a telephone set, another end user, another telephone set, and another telephone set here. Now this A, B, C and D, you have got four end users which are connected through a telephone line link. Now these two are also connected. If A wants to communicate with B using the procedure of circuit establishment, it can establish a link and the link will be established only through the local path. That means with the help of the end offices, this particular end office will be able to provide the path. There will be no need for any intermediate exchange. On the other hand, if C wants to communicate with D, the link will be established in this way, through this intermediate exchange. So in this way you can have several exchanges within the country, and if necessary you can go beyond the country. You can make international call and then several exchanges crossing different countries. The path will be established, link will be established. So this is how the circuit establishment is done. In public telephone network. Now, one important point I told you, that the end offices are not fully connected. For example, the United States is having about 20,000 end offices. Now, if they are fully connected, the number of links between exchanges will be about 20,000 into 20,000 minus 1 by 2. That's a very large number, and that is usually not done, and that is the reason why you have to use a number of or several intermediate exchanges to establish a circuit. And for that purpose you will require those switching equipments which are known as exchanges. Let us look at the basic elements of the switches. What are the basic elements of the switches that allows you to provide this data communication in a transparent manner? Let it be the exchange or switch, whatever you call it. It has got three distinct parts: control unit, digital switch, and network interfaces. And network interfaces are used for connecting to either end users or for connecting it to another exchange. What is the purpose of different components? First of all, network interfaces. These network interfaces, as I said, they provide the necessary hardware for establishing a link between the end user and the equipment. And we have already discussed how this can be done with the help of a modem and what kind of signaling is used. Those modulation techniques are used for that purpose, and necessary interface is provided which provides that. Second is digital switch. That is actually the heart of the equipment, and this switch provides the path. That means when you want to establish connection, the link is connected through this digital switch, and if it is not within this exchange, then it goes to another exchange connected through another interface. And the control unit does those three functions: circuit establishment, circuit maintenance, maintenance, and finally disconnection. Whenever one of the party wants to disconnect. All these three functions are implemented with the help of this control unit by suitable signaling. So the control unit is responsible to generate necessary signaling to provide these three functions of a circuit switch network, that is circuit establishment, circuit maintenance when the data transfer is going on, and circuit disconnection when the data transfer is over. Now let us consider the advantages and disadvantages of this circuit switch network. Advantages. First advantage is no delay. After the path is established, as we have seen, let us look at this diagram. This will give you good idea. After this initial call setup, data is going without any delay. There is no delay in the intermediate nodes or switches. Only delay that is involved is the communication delay. And it depends on the distance. As you know, the electromagnetic signal which is passing through the guided communication media, and that speed is 2 into 10 to the power 8 meter per second. So you can imagine when the signal is passing at this speed, the delay will be insignificant unless distance is very large, which is true in case of satellite communication. Otherwise, this delay is very small, and this is very suitable for continuous type traffic. The reason is, once the circuit is established, the path is dedicated. And as a consequence, it is good for continuous traffic. If you don't have continuous traffic, the path, that means the bandwidth which has been allocated to you, is a waste. And another advantage is there is no overhead after call setup. We have seen there is some delay for call setup, but after the call setup is done, it involves no overhead. There is no need to provide the address of the destination or any other bit to identify where it is going. As if you have established a pipe and through which whatever you send will reach the destination. So there is no overhead, and that is another reason why it is called transparent. That means the data that you are sending is continuously reaching the destination without any delay in order, and that's why we call it transparent. Let us look at the disadvantages. Nothing in this world is one-sided, so there will be some disadvantages. What are the disadvantages of this circuit switch technique? First disadvantage that everybody will notice is the call setup delay. There is some initial delay for setting up the call that we have seen here. This time is initially necessary for setting up the call, so this delay is involved in switch network, and it is inefficient for bursty traffic. It is good for voice communication. One of the two parties are always talking, so the channel or the link that is being provided to you, the circuit which has been established, is being used continuously. But when you have a bursty traffic, as it is true when a terminal is connected to a server, then the traffic between the terminal, computer terminal, and the server is not continuous. It is bursty in nature. At certain point of time there is more number of data, and at certain point there is no data at all. But in circuit switch network we have seen that it will be wasted. That path is dedicated to it, so it will be wasted. That's why it is inefficient for bursty traffic. And another disadvantage is it provides you fixed bandwidth. Fixed bandwidth because you have established a circuit, and data rate, the rate at which the communication will take place, is decided by the sender's data rate. It cannot be changed in between. Although some of the paths, for example between 3 and 5, there may exist high speed path. That means 3 and 5 can communicate at a higher data rate, but that cannot be used in circuit switch network, because the from A to D, A to B, the data rate has to be same and fixed. Another disadvantage is when load increases, some calls may be blocked. The reason for that is you will not be able to establish a circuit. For example, A is doing data communication with B. Now C wants to communicate with D. You will find that only path that exists between node 1 and node 2 is being used up by A and B. So C will not be able to establish a circuit by using call request between C and D, and as a consequence this particular call by C will be blocked. So these are the disadvantages of circuit switch network. and this can be overcome by using packet switch network. Some of the disadvantages can be overcome by using packet switched and message switching networks. Packet switching and message switching networks. Let me very briefly tell you about message switching network. In message switching network, you have several stations, say A, then B, and C, let's assume. These stations are connected to nodes, say N1, N2, and N3. The nodes are connected, let's assume, in this way. Here, the basic idea is store and forward. Instead of establishing a link, in this case, no link is established. No link is established. Between A and B or A and C. So initially, no link is established between any pair of nodes. So in this case, what happens? Whenever A wants to send to B, suppose the path is through this. What will be done? A will send it to node N1, where there is a storage medium, where it will be stored. Then when a path is available between N1 and N3, it will send it to node N3, which is also provided with storage facility. Similarly, when this path is available, N3 will send it to N2, where it will be stored once again, and that can be accessed by B. So the communication is taking place in this manner. Assuming that there are 4 nodes, 1, 2, 3, 4, between a pair of stations, here there is no initial call setup time. First, it is sent from 1 to 2, the entire message is sent if a path is available, and which is being stored in node 2. When node 2 gets a path, it sends from 2 to 3, there may be some delay in between, and it is sent. Similarly, when a path is available from 3 to 4, it is sent from 3 to 4. And there may be variable delay here. Now let us see the advantage and disadvantages of this technique. Advantage. Let us consider the advantage first, then we shall consider the disadvantages. First advantage is no call setup delay. And as there is no call setup delay and no dedicated path is established, what it can do, it can make good use of the channel or the bandwidth of a channel. So makes good use of the link capacity. Because when a particular when a pair when there is no data to be sent between a pair of nodes, that can be used by some other stations. So it is being shared. It is unlike the circuit switching technique where it is unused. Here it is used. It can be used by some another pair of stations. So these are the two main advantages. So what are the disadvantages? First disadvantage is requires large data storage. Here we have seen that each node is provided with some storage facility, and the message is stored. It can be arbitrarily long, and when you are sending long messages, they have to be stored in the intermediate nodes. So that will require very high storage capacity. Another disadvantage is when message is very long, it blocks internodal links. That means when you are sending long data between say 1 to 3, this link is getting monopolized by the particular message that is being sent from node 1 to node 2. And this can be avoided by using other techniques which we shall see very soon. And because of these problems, not suitable for interactive traffic. Because of arbitrary long delay. We shall see how the drawbacks of message switching can be overcome by packet switching technique, which is one of the most dominant technique used nowadays, and that we shall do in the next class. Thank you.